Take one.
Hold up! Progress in science.
Build a wall.
Wait, cut. That's uphold scientific progress, you fools.
I'm sorry.
My mistake.
Whoops.
Take two.
Uphold progress in science. Tear down the wall.
Tear down that wall.
Today, we take for granted the concept of the atom, but it has a long and troubled history. The concept of the atom emerged surprisingly early, around 500 BC, in both India and Greece, and the atom was coupled with the idea of a void. Atoms moved around and combined in the void. In India, a philosopher named Acharya Kanad observed that objects broke down into particles. So he deduced that all objects must break down into particles too small to see. A very original idea. The atom and the void represented the basis of all nature.
Hi there. I'm Democritus, the famous Greek who formulated the concept of the atom. Here's my theory. All of nature is made up of just atoms and the void. All objects break down to tiny, invisible atoms. These atoms come in different shapes. They are infinite in number. They are eternal. They cannot be destroyed. As atoms move about in the void, they connect to each other to form larger objects. These movements and combinations are not by chance. There is no free will.
The atomic theory was not generally accepted in the time of Democritus, largely because of its deterministic character. It leaves no chance, no choice, no free will.
I'm Plato. I certainly do not believe that atoms are the most fundamental component of nature. A bunch of invisible particles could not possibly produce all the objects we see. According to me, the fundamentals of nature are fire, earth, water, and air. And these are made of geometric forms, like triangles. Those geometric forms are more fundamental than atoms.
I'm Epicurus. I believe that Democritus was correct. The atom is the basic object in all nature, but I'm not so sure that the atom is the basis of all phenomena. For example, lightning and earthquakes may not be related to atoms. And here's something important. The motion of atoms is not predetermined, as Democritus argued. Instead, atomic motion is random. I call it the swave. And that's important because it allows for randomness.
The atomic model was not generally accepted among later generations of Greek philosophers. Aristotle, in particular, refused to accept the idea that the natural world could be reduced to a random assortment of atoms moving through a vacuum.
I'm Aristotle, and I'm telling you that the elements of all nature are the four elements of fire, air, earth, and water. And these are not made of atoms. The four elements are not particles, but continuous forms. When you break down an object all the way to the invisible, each particle is a miniature of the original form. And change from one form, such as clay, to another form, such as a vase, is not a rearrangement of atoms. The new form is just a result of a potential of the first form. The atom moving through a void is complete nonsense. I'm Lucretius, a strong believer in the atom as the basis of nature. I made some important changes. First, I emphasized that the atom moves randomly. And also, I argued that atoms differed in size and texture. For example, a sour taste of a food was due to rough atoms in the food, and a sweet taste was due to smooth atoms in the food. And I described the kinetics of atomic theory in my famous piece called De Rerum Natura.
After the fall of the Roman Empire around 300 AD, many great intellectual accomplishments of the ancient Greeks, including the atom, were lost. For centuries, known as the Dark Ages, later the Middle Ages, up to 1500 or so, Christian Europe was quite ignorant. The atom concept resurfaced occasionally from around 1000 AD onward, but largely through contact with Jewish and Islamic philosophers in the Byzantine Empire. Finally, in 1650, Pierre Gassendi revived the atom concept of Epicurus and made it acceptable to the church, which, remember, strictly controlled ideas about nature. The concept of the atom was further promoted by René Descartes, Isaac Newton, Robert Boyle, and others much later. This acceptance of the atom was an important part of the gradual shift in Europe from philosophy, especially Aristotle, and magic, like alchemy, to real science. The atom was associated with randomness and unpredictable, and those characteristics were very controversial. This resistance began to change in the time of Newton in the 1600s. And at that time, the atom concept was more natural for chemists and their precursors, the alchemists, than for physicists.
Hi, I'm John Dalton. I studied the nature of gases and compounds, and I realized that gases must consist of tiny particles in constant motion. My idea of the atom was like the Greek one, a solid, invisible object. But I expanded the idea to include atomic weights for specific types of atoms, which we call elements, such as oxygen and hydrogen. And I described how elements must combine to form compounds. So, for example, a molecule of water, also known as H2O, would be 2 hydrogen atoms and 1 oxygen atom.
Hi, I'm Robert Brown. I'm a botanist. In 1827, I happened to observe that pollen grains on still water moved about in a random manner. That was odd. I couldn't understand why the grains moved at all. It was difficult to explain this swarming motion of the tiny grains.
Decades later, in 1905, the great physicist Albert Einstein explained Brown's observation. The random motion of the pollen grains, which Einstein named Brownian motion, could only be due to invisible water molecules striking the grains. This was the first definite proof of the existence of atoms.
Hi there. I'm J.J. Thompson. Wow! In 1897, I discovered the electron. So now the atom was more than just an invisible round hard pellet. In my concept, the atom consists of charged positive particles, with the electron and its negative charge distributed throughout the atom. This became known as the plum pudding model.
Around the time in the early 1900s that Einstein wrote about Brownian motion, another great physicist, Ludwig Boltzmann, developed a theory of probability to explain the unpredictable motion of atoms. This theory provided a mathematical explanation for Brownian motion, but despite the credibility of Boltzmann's theory, a number of physicists, very prominent ones like Ernst Mach, strongly resisted the concept because chance or uncertainty determined the motion of invisible atoms. In the evolution of science over the centuries, the notion that chance plays an important role in certain phenomena, certainly in the motion of atoms, was very controversial. But the atom concept was gradually developed now by physicists. Ernest Rutherford in 1911 discovered the atom's nucleus in a very famous experiment and developed a model of the atom as an invisible object consisting of mostly empty space with a positively charged nucleus at the center and negatively charged electrons orbiting. Thereafter, the modern concept of the atom quickly evolved. In 1913, physicist Niels Bohr elaborated on the orbits of electrons around the nucleus. And the contemporary concept of the atom is associated with quantum mechanics, and it is more like a cloud. So today, after 2,000 years, the atom is a fundamental component of modern science.